Welcome back, everybody, for another deep dive. This time, we are going to be tackling something pretty complex and
Yeah.
pretty fascinating, the intersection of quantum physics
It's a good one.
and space exploration.
It is.
You guys sent in some really interesting
Yes.
articles and research on this.
Lots of good stuff.
So excited to unpack it all with you.
Absolutely. I think it's a field
Yeah.
that's really ripe with potential, for centuries.
Right.
We've been kind of limited by the laws of physics as
Yeah.
we know them.
Yeah.
But quantum physics offers this whole new set of rules.
It's like we're finally starting to glimpse
Yeah.
the cheat codes to the universe.
Yeah.
And one of the biggest cheats we've discovered
Right.
is this thing called quantum entanglement.
Yes. Quantum entanglement.
Yeah.
So this is the phenomenon where two particles,
Okay.
no matter how far apart, are intrinsically linked.
Yeah.
You change the state of one, and the other changes instantaneously.
So
Yeah,
it's like
yeah.
you're communicating faster than the speed of light,
Yeah, that's where things get,
which is supposed to be like the
But-
ultimate speed limit.
well, that's where things get really interesting and a bit
Yep.
mind-bending.
Yeah.
It's not that information is traveling faster than light in traditional sense.
Gotcha.
It's more like these entangled particles
Mm.
are part of a single system,
Okay.
no matter how much space separates them.
Yeah.
So a change to one is a change to the whole system.
I'm trying to wrap my head around that.
Yeah.
So even if these particles are light years apart,
Right.
they're still connected on some fundamental level.
It's like they're two sides of the same coin,
Oh,
even if that coin is stretched across a galaxy.
okay.
And this seemingly impossible connection
Yeah.
has some very real implications for space exploration.
You're talking about communication, right?
Yeah, exactly.
Like being able to send messages across vast distances
Yeah.
instantly.
Precisely.
Like no more waiting years
Yeah.
for signals to travel between
Yeah.
planets or spacecraft.
Imagine a future where we could have real-time conversations
That would be
with astronauts on Mars,
incredible.
or even receive data from probes
Yeah.
exploring distant star systems
Yeah.
without any delay.
Okay.
It would revolutionize our ability to explore and understand the cosmos.
But how do we go from this like theoretical concept of entangled particles to actually building a communication system
That's the challenge.
that can send messages across the universe?
Yeah, we're still in the early stages of
Right.
understanding and harnessing
Yeah.
quantum entanglement, but scientists are already working on developing these technologies that could make it a reality.
It makes you wonder if we could communicate instantly
Yeah,
across the galaxy. Who would we talk to
right.
and what would we say?
Now that's a question for the ages.
All right, so we've tackled communication,
Okay.
but even with instant messaging across galaxies,
Right.
getting from point A to point B in space is still a major hurdle.
Absolutely.
Our current spacecraft are
Yeah.
incredibly slow compared to the vastness of the universe.
Yeah, you're absolutely right.
It would take generations to reach.
Our current understanding of physics,
Yeah.
specifically the speed of light, puts a hard limit on how fast we can travel.
Right.
Right.
But
But quantum physics
might offer a workaround.
might offer a workaround.
You're going to tell me about quantum propulsion.
One of the more speculative
I've read some pretty wild theories about this.
areas of research, but the idea of manipulating
Yeah.
quantum phenomena to
Yeah.
achieve faster than light travel
Right.
is something that some physicists are seriously exploring.
Okay. This is where I need you to break it down for me.
Okay.
How could quantum physics possibly allow us to bypass the speed of light?
One concept that's often mentioned is quantum tunneling.
Okay.
In the quantum world,
Yeah.
particles can do things that seem impossible
Yeah.
according to classical physics.
Okay.
For example, a particle can pass through a barrier even if it doesn't have enough energy to do so.
Okay. That sounds pretty bizarre.
It's like walking through a wall.
But how does that translate to moving a spacecraft?
So the idea, and it's still very theoretical, is that if we could manipulate the quantum state of a spacecraft, we might be able to make it tunnel
Okay.
through space-time, essentially bypassing the limitations of traditional travel.
So instead of physically traveling through space, the spacecraft would kind of blink from one location to another,
That's a simplified way of putting it.
like teleportation.
But it gets at the basic idea.
Yeah.
It's important to remember that this is all still very much in the realm of theoretical physics.
I'm starting to see a pattern here. Quantum physics is basically rewriting the rules of the game
Exactly.
when it comes to space exploration.
We've been playing checkers,
Right.
and suddenly someone has introduced us to the complexities of chess.
And to continue that analogy,
Mm-hmm.
it seems like we need a more powerful computer
Yes,
to help us play this quantum chess game.
that's a crucial point.
Our current computers might not be up to the task
And it leads us to
and of
the
processing the vast amounts of data
Sure.
we'd be collecting from these advanced space missions.
Quantum physics, quantum computing.
Right.
Our current computers rely on bits,
Okay.
which can be either a 0 or a 1,
Right.
but quantum computers use qubits,
Okay.
which can exist in multiple states at once.
So quantum computers can essentially multitask
Exactly.
on a level that our current computers can't even fathom.
This allows them to tackle
Whoa.
certain types of problems
Oh.
exponentially faster than classical computers.
So we're talking about a whole new level of computing power.
Problems like simulating the behavior of black holes,
Mm.
analyzing complex data from distant galaxies,
Okay.
or even cracking the codes of the universe itself.
But how does this translate to real-world applications in space exploration today?
A good question.
I mean, are we already using quantum computers
That's so cool.
to explore the cosmos?
In the early stages, but
Yep.
NASA and other space agencies are actively researching and developing
Mm.
quantum computing applications for space exploration.
Like what?
Well, one area where quantum computing could have a huge impact
Okay.
is in mission planning.
Okay.
The complexity of space missions with all the variables and calculations involved
Mm-hmm.
can quickly overwhelm even our most powerful computers.
Yeah.
But a quantum computer could potentially analyze all that data
Yeah.
in a fraction of the time,
So it's not just about pie-in-the-sky ideas like faster than light travel.
allowing for much more efficient and sophisticated mission planning.
Quantum computing could also improve the way we explore space right now.
Exactly. It's about optimizing what we can do today
Yeah.
while simultaneously pushing the boundaries of what's possible for the future.
This is all so fascinating.
Yeah,
But I have to admit, my brain is starting to feel a bit overloaded.
I can understand that. It's a lot to take in.
Maybe we should pause here for a moment.
Yeah.
Let our listeners digest all this incredible information
Right.
about quantum communication, propulsion, and computing.
It's heady stuff.
I have a feeling we're only scratching the surface
I agree.
of what quantum physics has to offer the world of space exploration.
We've only just begun to explore the possibilities.
We'll be back in a moment to continue our deep dive
Okay.
into this mind-blowing topic. Don't go away.
Sounds good.
Yeah.
Welcome back. Before the break, we were talking about the power of quantum computing and how it's being harnessed to tackle real-world challenges in space exploration. But there's another fascinating aspect of quantum physics that we haven't touched on yet,
Okay.
quantum sensing.
Okay, quantum sensing. What's that all about? Is it like having some kind of cosmic sixth sense?
In a way, yes. Quantum sensors are devices that use the principles of quantum mechanics to detect incredibly faint signals
Okay.
and measure phenomena with unprecedented precision.
So what kinds of things can these quantum sensors detect
Yeah.
that our current instruments miss?
Well, one area
Give me some concrete examples.
where quantum sensors are showing incredible promise is in the detection of gravitational waves. You probably remember when scientists first announced
Yeah.
the discovery
A huge deal.
of gravitational waves.
Yeah, proof of Einstein's theory of general relativity
Exactly.
and a whole new way of observing the universe.
And with quantum sensors,
Yeah.
we can take this discovery to the next level.
Okay.
Current gravitational wave detectors are limited in their sensitivity, but quantum sensors could potentially detect much fainter waves,
Okay, so what kind of events?
opening up a whole new window into the universe's most dramatic events.
Are we talking about? Give me some specifics.
Well, imagine being able to detect the faint ripples in space-time caused by the collision of supermassive black holes billions of years ago,
Oh, wow.
or the birth pangs of the universe itself.
That's mind-blowing.
We're talking about events that are so distant
Yeah.
and so subtle that they're currently beyond our reach.
It's like having a time machine that allows us to listen in on the universe's earliest moments.
It really is.
Wow.
And it's not just about looking back in time.
Okay.
Quantum sensors could also revolutionize our search for life beyond Earth.
Okay, now you've really got my attention. How could quantum sensors help us find aliens?
Remember how we talked about entanglement and how particles can be linked across vast distances?
Right.
Well, some scientists believe that we could use entangled particles to create sensors that are so sensitive
Mm-hmm.
that they could detect the subtle gravitational
Okay.
or magnetic signatures of exoplanets.
So we're not just talking about finding any planets,
Planets orbiting other stars.
but potentially finding planets that could support life.
Exactly. And not just life as we know it, but potentially life that is completely different from anything we can imagine.
This is incredible. It seems like quantum physics is opening up a whole new realm of possibilities for exploring the universe,
Yeah.
from communicating across vast distances
Mm.
to detecting the faintest whispers of cosmic events and even searching for extraterrestrial life.
And we haven't even touched on the potential of quantum computers
Right.
to analyze all the data we'll be collecting from these advanced missions. Imagine being able to simulate entire galaxies, map the distribution of dark matter,
Okay, now my head is really spinning.
or even predict the future of the universe.
This is all so exciting.
Yeah.
But it also raises some pretty profound questions.
Right?
I mean, if we're on the verge of making contact with other civilizations,
Yeah.
what does that mean for humanity?
Those are questions
Are we ready for such an encounter?
that philosophers and scientists have been grappling with for centuries.
Right.
And as we delve deeper into the quantum realm, those questions become even more urgent.
I think we need to take another break here and let our listeners ponder the philosophical implications of all this.
Okay.
We'll be back in a moment to wrap up our deep dive into the mind-bending world of quantum physics and space exploration. Stay tuned.
Sounds good.
Welcome back to our deep dive into the world where quantum physics and space exploration collide. Before the break, we were talking about some pretty big questions, the kind that keep you staring up at the night sky, wondering about our place in the universe.
Yeah, it's true. As we push the boundaries of science and technology, we inevitably bump up against these philosophical questions about the nature of reality, time, and even consciousness.
For example, we were talking about the possibility of using quantum entanglement for instant communication across the galaxy. But if we could actually do that, wouldn't that mean we're kind of messing with our understanding of cause and effect?
That's a fascinating point. Our everyday experience tells us that events happen in a linear sequence, cause and effect. But quantum entanglement suggests that there might be connections beyond our conventional understanding of time and space.
So if we could send a message instantly to another galaxy, are we influencing the past or the future? It's enough to make your head spin.
It certainly challenges our assumptions about the nature of reality. And it's not just communication. A quantum propulsion, if it ever becomes a reality, could allow us to travel vast distances in what seems like an instant. But what would that do to our perception of time and distance?
Yeah, it's like those classic thought experiments about traveling at the speed of light. Would time slow down for the traveler? Would they return to Earth years, decades, or even centuries later?
These are questions that physicists and philosophers are still grappling with, and they highlight the profound implications of quantum physics, not just for our understanding of the universe, but for our very understanding of ourselves.
And then there's the biggest question of all. What happens if we actually find evidence of other civilizations out there? What if those quantum sensors pick up signals from a distant planet that can only be explained by intelligent life?
The discovery of extraterrestrial life would be one of the most significant events in human history. It would force us to reevaluate our place in the cosmos, our understanding of biology, and even our definition of intelligence.
I can only imagine the cultural and societal impact of such a discovery. It would be like everything we thought we knew about the universe was suddenly turned upside down.
It would be both exhilarating and terrifying. We would be confronted with the unknown, the alien, the other, and it would raise profound questions about how we would interact with these other beings.
Right. Would they be friendly hostile? Would they have technology that's far beyond our own? Would we even be able to communicate with them?
These are questions we can't answer yet, but the very fact that we're asking them shows how far we've come in our exploration of the universe.
It's amazing to think that quantum physics, a field that was once considered purely theoretical, is now opening up these incredible possibilities for space exploration and for our understanding of the universe and ourselves.
It's a testament to the power of human curiosity, our drive to explore, to understand, and to push the boundaries of what's possible.
This deep dive has been an incredible journey, taking us from the subatomic realm of quantum mechanics to the vast expanse of the cosmos. We've explored the potential of quantum communication, propulsion, computing, and sensing to revolutionize space exploration and unlock some of the universe's greatest mysteries.
And as we continue to unravel the secrets of quantum physics, who knows what other wonders we'll discover, what other seemingly impossible technologies might become reality.
It's an invitation to keep dreaming, to keep exploring, and to never stop asking questions. To all our listeners out there, thanks for joining us on this deep dive. Keep looking up at the stars and pondering the mysteries of the universe. The future of space exploration is full of wonder and awe, and it's all thanks to the mind-blowing power of quantum physics. Until next time, keep exploring